So, am I audible to you?
Yes, sir.
So today we have to just revise the topic. First of all, I'm giving you some information regarding that term. Then I will give you some problem over that particular concept. Coulombs law. It defines you the force between any 2-point charges. Let's say we have charge Q1 and point charge Q2. If it is placed in vacuum at separation R, then electric force between any 2-point charges will be nothing but Fe is equals to some constant, which is called electric constant, product of point charges over square of separation between them. Okay. Now from this, if I'll give you or I will ask to define the graph between this particular force and this particular distance, separation between these two charges, you would have two different cases. First, to draw force versus separation, and next, to draw force versus 1 over r square. Okay.
Yes, sir.
Can you tell me the nature of the graph for this particular formula, for this relation and for this relation?
So for the first one, it will be hyperbola.
Which
The
type of
second,
hyperbola?
sorry, sir.
Which type of hyperbola?
Then inverse relationship.
Rectangular hyperbola. So it will be like inversely proportional like this. Okay, next for the second part.
It will be linear.
Linear, starting from origin or intercepting these two axes.
Starting from origin.
Okay, so it will be like this. On the basis of this particular term, if there is a question, if I have a pair of charge like 2 microcoulomb and 1 microcoulomb, the first part, and if I have charge 3 microcoulomb and minus 2 microcoulomb, can you draw the variation of force versus 1 over r square in these two pair of charges? Nazira, Nasir, any doubt?
No, sir.
Okay. Let's say we have y-axis as force and x-axis as separation between them. So try to define the nature of graph for this particular relation, for this first pair of charges and for this particular pair of charges. And r is the separation between them. For either of the two, having positive slope or negative slope?
So positive slope for the first one, negative slope for second one.
Okay. Since force is a vector quantity, the polarity of the charge will define you nothing but direction of force. Okay. So if you take vector notation, this particular polarity of charge just defines you the direction in which the force is acting. For that particular sense, either of the two charges will have same straight line, but since the product of these two would be just 2 into 1 becomes 2 and 3 into 2 becomes 6. So it will be 1 like this and the other one would be like this. If I take the vector component. If it is calculated in terms of scalar, so we would take the negative sign and positive sign as well. So it will be like this. Okay.
So the green line is for which case?
For the second case, this is your first case, this is your second case. If I have taken vector relation, so both graph will be in upward direction, as the polarity of charge for vector term defines the direction only. Okay.
Yes, sir.
But if in the case of scalar, or we are just taking the magnitude only, so we take the negative sign as well. So it will be this.
Okay, sir.
Is it clear, Nasira?
Yes, sir.
Okay. So next part is, as force is equals to K, Q1, Q2 over R square. K is electric constant, which is equals to 1 by 4 pi epsilon naught. What is this particular term here?
Absolute permeability.
Absolute permittivity. What does it define? Or what do you mean by just permittivity?
It defines what's the effect of medium on the force between two charges.
Okay. Whether it influences the force of interaction or it decreases the interaction.
So it can be both in different cases.
Suppose we are just considering in vacuum, so the force is this much. If it is kept in any of the medium other than vacuum, whether this particular force would increase, decrease, or remain same?
It will increase.
Increase. Let's say, first case, since it is in vacuum, so it will be F naught, which is equals to 1 by 4 pi epsilon naught, Q1, Q2 over R square. So we have permittivity as three different types. First, absolute permittivity or permittivity of vacuum. Similarly, permittivity of any medium, and a relation to define in between them, which is called relative permittivity, which is equals to permittivity of medium over permittivity of vacuum. So from this, we can define permittivity of medium is equals to relative permittivity times permittivity of vacuum. So for this case, if I have to calculate the force of any medium, it would be like 1 by 4 pi epsilon of medium, Q1, Q2 over R square. Put the value of this epsilon to this, it will become 1 by epsilon m times 1 by 4 pi epsilon naught Q1, Q2 over R square. And this is nothing but F naught. So it will be F naught over epsilon m. Is it clear?
Yes, sir.
Now, you must have know the value of this particular epsilon m. Its value will lie from greater than equal to 1 and less than or equal to infinity, depending upon values. So epsilon r, simply epsilon r. Epsilon r is equals to 1 for vacuum, and epsilon r is equals to infinity for any metal. The rest of the all part would lie in between them. So from this, we can define epsilon r is either greater than or equals to 1. So if denominator is greater than 1, so the whole ratio would increase or decrease. It will decrease by a factor of epsilon r. This is epsilon r, as we have substituted this. This is your epsilon r. So from this, we can define the force in any medium is lesser than the force in vacuum. Okay.
Yes, sir.
So permittivity actually tells you how much or to what extent a medium restricts the formation of electric field. Or in another way, you can define how much times a medium allows the interaction of charge. Okay.
Yes, sir.
In either of the way, you can define permittivity. Okay. So from this, if a charge system is placed in any other medium other than vacuum, the force of attraction between those charged particles would decreases. Okay.
Yes, sir.
Next part, superposition principle. What do you mean by superposition? Nazira, can you
Yes,
explain? Yes.
uh,
In physics, superposition means just addition of any two different terms. As we have two different types of quantities, one is scalar and the other one is vector. So while adding, we have to keep in mind whether the quantity going to be added are scalar behaving or vector behaving. On the basis of that, we apply superposition principle, or we have just relate the addition of that particular two different quantities. So it just tells you if the quantities are scalar, take the algebraic sum of all terms, and if quantities are vector, take the vector sum or using component method. So as we are discussing for force, so it tells you the net force acting on a single point charge due to a system of point charges is equals to vector sum of all individual forces. Okay.
Yes, sir.
So what do you mean by just vector addition of any two different quantities? I'm explaining you. Okay. If you have a question, 3-point charges are placed on vertex of an equilateral triangle like this. Here you have 4Q, Q, and minus Q. Let's say A, B, and C. And this is your equilateral triangle having side length L. We have to calculate, find net force on charge placed at first A and second B. I'm solving the first part. I will give you the second part. For the first part, let's draw this particular curve. We have to calculate net force on charge A. So this is your 4Q. This is your Q. First, the force on charge A due to charge B. Whether it would be repulsive or attractive.
Be
We
repulsive.
have 4Q, we have Q. So the force on this particular charge due to this charge would be repulsive, so it will be away from it, like in this direction. So let's call it as force on A due to B. Similarly, force on A due to charge C. As magnitude polarity of this particular charge at C is in negative, so the interaction between these two charges would be attractive or repulsive.
Attractive.
So it would be along this direction. Call this force on A by C. Now, I'm solving for this part. Force on A by B is equals to Ke, electric constant, Product of two charges is K Q1 Q2 by separation L square. Similarly, force on A due to C is nothing but K Q1 Q2 by separation L square. I'm just taking the magnitude only. Okay. Now we have two forces. Both of them are equal. So we can take F for this and F for this. Now, as force is a vector quantity, so while taking the resultant, we have to keep in mind these are vectors. So we take the vector addition. So this is your first vector and this is your second vector. To what angle these two vectors is inclined at this particular point?
120 degrees.
Good. As it is an equilateral triangle, so this inclination is 60 degree. So this inclination would be 120 degree. So we have two forces and there is angle between them. So the resultant of any two vector is nothing but root under. Nazira, can you explain the resultant formula? Resultant of any two vector R is equals to yes, Noor.
Sir, A square plus B square plus 2AB cos theta.
Good. A to AB cos theta. So we have A as F, we have B as F, and there is angle as 120 degree. So the net force from this particular equation could be easily calculated. Okay, just try to solve. Nazira, is it clear or in doubt?
Clear. Yes.
Nazira, just calculate this part and send your answer. Are you solving? Nazira?
Yes, sir, I'm solving.
Just see here, A is nothing but F. So it will be F square. Similarly, B has the same value as F. So it will be F square. The value of cos 120 is cos 120 is minus 1 by 2.
Yes, sir.
So it will be 2 times of S square minus 1 by 2. 2 and 2 gets cancelled out. Minus F square plus F square cancel out under root. So we're left with just F. Okay, Nazira? Now, if I have to calculate this particular force in terms of component method, draw a triangle like this. And draw an axis over it, vertical line and horizontal line as x-axis and y-axis. Okay, you have first force on A due to B along this direction, and there was next force on A due to C along this direction. So we have to resolve that particular forces along x-axis and y-axis as well. So this was your F and this was your F, and the total angle in between them is 120 degree. So if I draw horizontal line over there, it will be 60 degree and 60 degree. So break the component according to that particular inclination. So if a vector is inclined at theta, its horizontal component will becomes f times cos theta, and vertical component becomes f times sin theta. Similarly for this component as well, this component will become f cos theta, and another component along this direction will become f sin theta. Now, these two terms are equal in magnitude and opposite in direction. So the resultant would be nothing but 0. So we're left with just these two terms. So the resultant of these two terms will be becomes 2 times of f cos 60. So 2 times of f cos 60 is 1 over 2. 2 and 2 gets cancelled out. So we're left with f only. So by this method, can also solve that particular resultant on force acting on charge placed at A. Okay.
Yes, sir.
Now, from the previous question, try to calculate net force on this particular charge at B. Okay, Nazira, any doubt? Is it the same value F here as you have done in the previous question?
I got f root 15.
The value of F is?
F root 15.
I'm not asking about the net force. I'm asking about the value of F only.
It's kq square by L square.
Okay. But in the previous part, we have assumed F as 4kq square upon L square. Okay.
Yes, sir.
So they are not the similar. Azira, have you solved? Noor, I think your answer is wrong. It will be something different. Just check your answer, please. For the second part, we have to calculate net force on this particular charge B, which was Q. Here we have 4Q and here we have minus Q. So force on B due to A would be repulsive and along this direction. Force on B due to A is equals to 4 times KQ by L square. Similarly, due to this particular negative charge, these two charges will attract each other. So it will be along this direction. Force on B due to C. It will be KQ square by L square. Since the magnitude of these two forces are not equal, so if we take this particular term to be F, this particular term will become 4F. Okay, Nazira? Now, the next part is to define the angle between them. So it is equilateral triangle. So the angle between them at this is 60 degree. So the rest of the angle at this point would be 120 degree. Now, apply resultant formula and try to solve. Okay, Noor?
Yes, sir.
Please check your calculation. Now it's correct. Nazira, have you solved? For the resultant, just check first vector squared, second vector square times first vector times second vector cos of 120, which is minus 1 by 2. So this 2 and this 2 cancel out. So it will be 16 plus 1, 17 minus 4, 13 times f squared. So it will be under root of 13 times f. So if you put the value of f in this particular part, it will become under root 13 kq square over L square. Is it clear?
Yes, sir.
Nazira, any doubt till now?
I got the wrong answer.
Okay. Now it is clear to you?
Yes.
Okay. Should I proceed?
Yes, sir.
Yes, sir.
Okay. The next part in this particular Coulombs law is to define interaction between pendulum type problem simple pendulum. If you have a support at this and there is a vertical line for its reference. Two Bob carrying equal charge are hanged from this particular support. So due to repulsion, they will repel each other and goes apart like this. This is just your reference. So we have Bob here and Bob here carrying mass M and charge Q. The length of this particular string is L. So due to repulsion, due to these equal charges, there would be a repulsive electric force along this direction, and due to mass, gravity would acting along vertically down direction. Okay. So if they inclined at some angle theta with respect to vertical, so if I proceed this particular line to this way, this would also becomes theta. Now just take the separation between two Bob is to be x. This particular vertical line will divide this particular distance into two parts, so it will become x by 2. Is it clear?
So the electrical force is being produced by which charge?
Due to charge present on this Bob and this Bob, and each Bob carrying equal charge and having equal mass. Okay.
Yes, sir. Okay.
So there would be repulsive force. So this is called electrical repulsion or electric repulsive force. Now, if we have to define electric force between them, it will be F is equals to K, Q1, Q2 by separation x squared. Similarly, force due to gravity would be mass times mg. Now, for this particular theta, this is your base and this is your perpendicular. So we can take tan theta is equals to perpendicular over base. So this expression will become K Q square by mg times x square. Is it clear?
Yes, sir.
Now see in this particular triangle, here we have theta and this is your perpendicular and this is your hypotenuse. So if I take sine theta, it will be perpendicular over hypotenuse. So x would be equals to 2 times of L sine theta. Just put the value of x as this in this expression. It will be tan theta is equal to K Q square by mg times 4L square sine square theta. This is a final expression. So they will ask you to find the value of Q, find the value of length of string in terms of K and mg or either of the term. So just approach any of the problem related to simple pendulum by this way. Okay.
Yes, sir.
Now, if there is a relation or a condition given in this particular question as if theta is very small. So for very small angle, tan theta approx equals to sine theta, and which is approx equals to theta only. Okay.
Yes, sir.
Now just put value of theta in this particular part and put the value of theta from this as well in this expression. This particular equation will reduces to x and q only. Okay. So on reducing this particular equation, it will becomes theta q is equals to k q square over mg times 4L square. From this, if theta is small, it would be theta is equals to x over 2L. On putting the value of theta to this in this particular equation, it will becomes x cube over 8 times of L cube. So x cube is equals to k q square 2 times of L divided by mg. This will be a required answer in terms of x if theta is small. Is it clear?
Yes, sir.
Just write it down. They would just ask you to find this expression on the basis of these different conditions. Nazira, any doubt? Yeah. So they will ask you the result of these terms. Have you written this?
Yes, sir.
Now there is a relation. If you have a charge Q, and they will ask you, if I have to break this particular charge into two parts and separated them at some small distance t, what would be the relation between these two small segments for this particular charge, for which the force between those two segments would be maximum? Let's say if I divide this particular charge, first one is small q, the other one will be q minus q. And if they are separated at some distance t, then they would ask you, find relation between q and q so that force between them is maximum. Instead of solving, I'm giving you the result and I'm giving you how to solve this particular part. Just calculate force between these 2 point charges. It will be KQQ by separation R squared. You must have learned, if you have to calculate the maximum value of any function, how you would start to approach. Noor,
Yes, sir.
how would you calculate the value, maximum value of any function?
Writing
must-
cut max.
You must have sometime approach to, or sometime you must have noticed this particular part in any of the problem, like in your class 11, calculate maximum distance, maximum speed, maximum acceleration, and so on. So I'm giving you tips how to solve. For any of the function to get maximum or minimum, just differentiate that particular function and put it to 0. This is the main idea behind calculating maximum value or minimum value of a function. Similarly, if we differentiate this particular term and put it to 0, it will give you q is equals to q by 2. So just instead of doing the whole mathematics, just remember this result. They will ask you, okay, what is the relation between these two charges so that the force between them to be maximum? So you must say the charge must be divided symmetrically so that the force between them would be maximum. Okay,
Okay, sir.
just write this particular result. So just remember this particular concept. For maxima or minima, of a function. Just take the differentiation and put it to 0. Nazira, any doubt? Have you written this?
Yes, sir.
Okay. So we have just finished how to solve Coulombs law and problems related to that. The next part is electric field. Electric field is nothing but space around any charge in which if you place the other charge, it will experience some electric force. So for this particular electric field, we define field intensity. Field intensity, or simply strength of electric field or electric field intensity. It is denoted by E. Do you know the formula to calculate E in terms of force? No?
E is equal to F by Q.
Good. So A is nothing but F by Q, where F is force and Q is the point charge which is placed in that particular region. If I rearrange these terms, F would be nothing but Q times of E. Similarly, for this particular calculation of F in terms of mass, we can write force is equals to mass times acceleration. So from this, acceleration would be Q times of electric field divided by mass. Using this particular acceleration, they would ask you to define equation of motion, like V is equals to U plus AT, S is equals to UT plus half AT square, V square is equals to U square plus 2AS. I'm giving you one problem related to this. If an electron is moving at V0 and an electric field minus of E0 I cap is applied, find velocity at 2 seconds. Just try to solve using the above concept. This is your V0 initial velocity.
So mass is m only.
Just take the mass as m. Just use first equation of motion, put all the values and try to simplify them. There is one concept behind this. I'm describing that. Since the electric field is along negative x-axis, so it will be along negative x-axis like this, E naught. An electron is initially going along positive x-axis. So it is going along this direction with some velocity v naught. Since the charge of electron is negative, so we can write it as minus E. In which direction this particular charge would accelerate, towards negative side or positive side? Towards right or left?
Towards right.
Good. As electric field goes from positive terminal to negative terminal, so from this we can define negative charge accelerate towards opposite direction of external electric field. So since this particular charge electric field is in along negative side, so if you multiply charge of electron, negative and negative becomes positive. So acceleration for this particular part will becomes minus minus plus E times upon m along x-axis. So now use first equation of motion. V is equals to u plus a times t. U is v naught I cap, and acceleration is e naught by m, and time is 2 seconds along x-axis. So it will become 2 times of e naught by m, and the whole term would be along positive x-axis. Okay.
Yes, sir.
On just saying this particular electric field to be in negative side, and on putting the value here, the acceleration would never become negative. Just you have to also check the value of this particular charge. Okay,
Yes, sir. Got it.
good. Nazira, any doubt? There is another question on this particular concept. If you have plate which is generating electric field, suppose there is a plate which is generating electric field along this direction, and this is gravity-free region. Now, if a charged particle is being displaced along this direction between one terminal to another terminal, let's say charge is Q. So they will ask you, find the ratio of time taken to displaced from one to another if it is electron and if it is proton. Take initial velocity of the particle to be 0. No, is it clear to you?
Yes, sir.
Just use second equation of motion and try to solve. Any doubt while solving? No?
No, sir, I'm solving now.
No. Nazira, have you started to solve? Just see how to approach. Since we have initial velocity to be 0, so just use second equation of motion. S is equals to, okay, no problem, ut plus half times at square. Here u is 0, S is d, half, acceleration is qe divided by m times t square. So from this, t would be 2 times of m d over q times e, root under. This would be your expression for time. Now, for electron, TE is equals to root under mass of electron. So it would be ME times D divided by charge of electron is EE. I'm taking the magnitude as electron will move along this direction. So proton will move along this direction. So they will differ only in sign, but the value of time taken will depend upon these parameters. Okay. So we have this particular expression for time of electron. Similarly, for calculating time for proton, it would be 2 times mass of proton into D divided by charge of electron and proton remains same. Now, on taking the ratio of these two to part, all the term would cancel out. We're left with nothing but root of mass of electron and mass of proton. Okay, no?
Yes, sir, I forgot the root sign.
Okay, since we have a square here, so it will become under root. So if they will ask you which will take longer time, so what would be your answer? You will say mass of proton is 1837 times mass of electron. Proton is much heavier as compared to electron, and time is directly proportional to the mass of the particle. So proton will take longer time to move the same amount of distance in that particular electric field. Is it clear?
Yes, sir.
But there is a condition. If in case of gravity, time is equals to root under 2 times of d by g. Here time is independent of the mass of particle, but in this condition, time is mass dependent. So we can say any of the particle is thrown between any two different region. If distance between the two region is same, then it will take similar time or equal time. Okay,
Yes, sir, understood.
Nazira, any doubt? Okay, just write it down. And on the basis of these particular concept, try to solve more and more problems. Okay. We'll stop here and we may continue in our next class. I will define you how to solve dipole problem and Gauss theorem different problems. Okay.
Okay,
No?
sir. Okay, sir.
Okay then. Good night.
Thank you, sir.